So the equation for a quadratic in the turning point form is just y equals a times x minus p squared plus q. And the reason it's called the turning point form is because it's going to greatly assist us in finding our turning point and our line of symmetry. And we'll see that in just a moment. So let's take a look at an example. It might be y equals 2 times x minus 1 squared take 8. Well, first of all, let's say we're looking to try and find the y-intercept. So we know that the y-intercept, that is when x is equal to 0. So 2 times 0 minus 1 squared minus 8. So it's just 2 lots of 1 take 8, which is minus 6. So we get a y-intercept at 0, negative 6. Next up would be trying to find our roots or our x-intercepts. Now remember, this is just when y is equal to 0. So we have our equation and we need that to be equal to 0. Okay, now this is kind of like we're halfway through completing the square almost. So it's a similar sort of process in how we would solve this. So let's add 8 to both sides. So we get this, and then divide by 2. So then x minus 1, taking the square root of both sides, could be plus 4 or minus 4. So, plus or minus 2, my apologies, because we take the square root of 4, plus or minus 2. So x could be 3, or x could be minus 1. So our x-intercepts would be at 3, 0, or minus 1, 0. Okay? Now, next up is our line of symmetry. Now, this is kind of where the magic happens for the turning point form. So our line of symmetry is x equals, it's just whatever our p value is. So see how it says x minus p? So because we've got x minus 1 here, our p value is just 1. So x equals 1 is our line of symmetry, which means our turning point, we could put x into this equation, but what we actually end up with is just our q value. So our turning point is actually at p, q. So that's kind of cool, our turning point form. So in this case, our q is minus 8, so our turning point is at 1, minus 8. So p, q. So line of symmetry is at p, and the turning point is p, q. So we get 1, minus 8 is our coordinate for our turning point. Now, if we had to sketch this guy, we come over to our graph. Now our y-intercept is at 0, minus 6, so we're sort of down here. Our roots are at 3 and minus 1, so we are here and here. And our turning point is at 1. So sorry, our line of symmetry is at 1, and our turning point is at negative 8, so a bit below the y-intercept, so we're sort of down there. And if we connected these, we end up with this parabolic shape, which we would expect for a quadratic. Let's have a look at another example. So it might be y equals negative 3 x minus 2 squared. And remember, the general form, I'll write it over here, is a times x minus p squared plus q. So first of all, our y-intercept. Well, our y-intercept is just when x is equal to 0, so we just plug that in. We get negative 3 times minus 2 squared, so we are at minus 12. So at 0, minus 12, we get ourselves a y-intercept. Let's have a look at the roots, or the x-intercepts, or our solutions. That's when y is equal to 0. So we need our equation to be equal to 0. So let's divide both sides by negative 3. I just get x minus 2 squared to be equal to 0. So this can only happen if we take the square root of both sides, x minus 2 to be plus or minus the square root of 0, which is just 0. So I only get the one root here. I get when x is equal to 2. So I get my coordinate 2, 0 as my root. I won't highlight it just yet. I'll highlight it as we plot it. So that's my x-intercept. Now we know that if I've only got one x-intercept, then that has to be my turning point. But let's just check. So if I come over for my line of symmetry, we've said that that is when x is equal to p. That's just a cool thing to remember for our turning point form. So in this case, our p value, x minus 2, x minus p, so our p is just 2. So x equals 2 is my line of symmetry, which means my turning point, remember, is at p comma q. So it's going to be at 2 comma, well, I don't have a q value here, right? I'm just at plus 0. So it's 2 comma 0, which is exactly what we see for our x-intercept. So to sort of visualize this, if I plot this over here on the right of the screen, we have ourselves a y-intercept at 0 minus 12, so we're all the way down here. And then we have an x-intercept, we have one root at 2 comma 0, so that's going to be there. And then we have our line of symmetry and our turning point. So our line of symmetry is on that root, and our turning point is the root. They're the same thing. Now this thing is a negative quadratic, so it's going to be a sad face. So it's actually going to come up through here, turn on our root, and come back down symmetrically the other way. So it's a sad face quadratic because we've got our minus 3 out the front here. Let's look at one more example. So y equals 2 times x plus 3 squared plus 4. So our y-intercept, when x is equal to 0, so we get 2 times 3 squared plus 4, which is just 22, if you crunch those numbers. The x-intercept, remember, that is when y is equal to 0. So when our equation here is equal to 0. So 2 times x plus 3 squared must be minus 4. So x plus 3 squared must be minus 2. So when I divide both sides by 2 there. So let's take the square root of both sides. Plus or minus the square root of minus 2. But I kind of run into an issue here because we can't do the square root of minus 2. Can't take the square root of a negative number. So we actually end up with the answer that there are no solutions. So we have no roots. There isn't an x-intercept present for this quadratic. And we'll see what that looks like graphically in just a moment. Our line of symmetry, we just take straight off of our equation. Now remember, the general equation for turning point form is like this. Now, x minus p, but here I've got x plus 3. So this is kind of the same as x take away minus 3. So my line of symmetry here is actually going to be at negative 3. So make sure you look out for that. Don't let that slip you up. So the line of symmetry is at minus 3, which means my turning point, remember that's just at p comma q. So that's just going to be at minus 3 comma 4. Because my 4 here is my q value. Let's plot this. So here is my best effort at a Cartesian plane. And we have our y-intercept all the way down here at 22. I really should write that as a coordinate. So at 0, 22. So we are all the way up there, right at the top. We don't have any roots. Our line of symmetry is at minus 3. So we're coming down like this. And our turning point has to lie on our line of symmetry at positive 4. So we're actually sat like that. And this thing is a smiley face quadratic. So it's going to look something like this. So we can see there that we've got no roots. So that's graphically what that's going to look like. Now we can kind of see that happen as well. In the standard form, we can end up with no roots. Because if we do our quadratic formula and we end up with a negative number underneath our square root sign, there's going to be no roots present there either. Hopefully that's helped understand the turning point form for a quadratic. So we've looked at the turning point, the root form, and the standard form. So that's all three. So hopefully you'll be well equipped with a few skills on how to actually sketch these equations depending on what they look like.